Hello. Oh
Hello,
yeah.
sir.
Can you see the screen?
Yes, sir.
So let's start today's session. So we are going to study elimination reaction. Okay. Any problem in SN1, SN2 reaction? You can ask me.
No, sir.
No, sir.
Okay. So have you done the previous work regarding if you have got elimination reaction? Sorry, SN1, SN2 reaction.
Yes, sir.
Okay. No issue. No
No
problem.
issue. No problem.
No, sir.
Good. Elimination reaction. So from the name, you can understand that something is going to be eliminated, right?
Yes, sir.
Yeah. So actually, in this thing, the hydrogen and one living group is to be eliminated, and in that place, pi bond will form. So let's write the definition first. We will discuss. So we are studying, still studying haloalkane chapter. Okay, so regarding that only, when haloalkane. Note down these definitions. We will understand it by examples. You two people were present in last class, right?
Yes, sir.
So I have introduced you what is alpha carbon and beta carbon, alpha hydrogen, beta hydrogen.
Yes, sir. But sir, can you explain it again to me?
Yeah, I will explain. No worries, no worries. I will explain again. Adija,
Yes, sir.
and do you remember I have taught alpha carbon, beta carbon?
Yeah.
So actually, I have taught you nearly 80% of the general organic chemistry. The last class we have revised it so that in upcoming organic things we will relate, and it will be easy for us. Write down these definitions, then we will discuss. See, have you written?
1 minute, sir.
Okay, okay.
Done, sir.
Khadija, what is your status? Khadija, done?
Yes, sir.
Okay. Okay. So where are we? Hmm. See, so let's introduce. So in this, we have one hydrogen present and one, a halogen is present. Okay. So and rest, carbon has 4 bonds. So this is halogen with this carbon, right? So this carbon will be known as alpha carbon. This carbon will be known as alpha carbon. And the next carbon, the carbon attached with this alpha carbon will be known as beta carbon. Okay.
Okay, sir.
So this is the main thing. How you have to identify alpha carbon and beta carbon. Alpha carbon is the carbon on which halogen is attached, and the next as carbon attached with alpha carbon is known as beta carbon. Okay. Let's see. Like here, what was the definition? The alpha carbon was the carbon which is attached with carbocation, right? So in this example, can you see it here?
Yes, sir.
Yes, sir.
In this definition, the alpha carbon will be the carbon on which halogen is attached, and the next carbon will be known as beta carbon. Okay.
Okay, sir.
And the number of hydrogen atoms connected with beta carbon will be known as beta hydrogen. This will be known as beta hydrogen. It can be 1, 2, 3, right?
Yes, sir.
So the thing is, this hydrogen and this hydrogen will be get eliminated by the definition. You can see when the haloalkanes having at least one beta hydrogen. This is very important. We will see that at least one beta hydrogen should be present, and when it is reacted with alcoholic KOH. Okay. So when it is reacted, this is the reagent. Then there is elimination of H atom from beta carbon. See, the H atom has been eliminated from beta carbon, right? This H atom has been eliminated, and halogen from alpha carbon, and halogen from alpha carbon. This is a halogen. Okay, this has been eliminated, right?
Yes, sir.
So we will get the alkene in the final product. So let's make the final product. We will have the reagent alcoholic KOH. We have alcoholic KOH, and we will get this alkene. We will get this alkene. Here you can see these two sigma bonds are breaking and one pi bond is forming, right?
Yes, sir.
So CH bond and CX bond are breaking, and this beta carbon and alpha carbon bond is forming. Are we good till here?
Yes, sir.
Khadija?
Yes, sir.
So since beta hydrogen is gone, okay, so that is why it is called beta elimination reaction.
Yes, sir.
So let's move to the next point. So note it down till here. I'm writing next points. Have you written here till? Have you written this till here?
Yes, sir.
Yes, sir.
Okay. So this reaction is also this is mentioned in your book. This reaction is also called dehydrohalogylation because hydrogen and halogen, as you can see, this hydrogen and halogen both are getting removed from the substrate, and substrate is what? The reactant, the organic reactant, right?
Yes, sir.
So there are other reagents also which can be used for this beta elimination reaction. So the first one is alcoholic KOH or alcoholic NaOH. What is alcoholic KOH or NaOH? It is actually C, alcohol means ethyl alcohol, C2H5OH. Na? So this is alcoholic KOH. And the second one, you can say this RONA or ROH. Third, if you will see these reagents in your reaction, get confirmed that these are beta elimination reactions. Okay, note these down.
Done, sir.
Done. Okay. So, so these are the when you will see these are the popular reactants. When you will see them, just remove this, this halogen, and make this, alkene. Okay.
Okay, sir.
Okay. So let's compare some rate of elimination also. Rate of elimination, very easy. Rate of elimination, you can compare it with SN1, SN2 also. That when I will write it, you will understand. RF is lesser than RCl, is lesser than RBr, is lesser than RI. What is happening? Bigger the, the reason. Anyone?
Bigger the molar mass.
Bigger the size. See, bigger the size, better will be the leaving group. See, can you see these halogens are leaving groups, right, Khadija?
Yes, sir.
Yes, sir.
Huh. So the bigger the size will be, they will be easily leave the, leave this substrate. Okay, simple.
Yes.
Now let's give you some questions. Write this thing. In the meantime, I'm writing the question. Tell me. Solve this question in within a minute. Try to solve this. Just write the identify the. Have you written the question?
Yes, sir.
Yes, sir.
Just below it, identify the alpha carbon and beta carbon. Then proceed with the question. First write the alpha carbon and beta carbon. Then it will be very easy for you. Have you marked? The most important thing is to identify alpha carbon and beta carbon. Then you can, proceed with the answer and it would be correct also. Done with the, marking the alpha carbon and beta carbon. I
Yes,
think this one was easy. Khadija, done.
Yes, sir.
So tell me, how many alpha carbons you can see here in this thing? How many alpha carbons? Yeah, here. How many alpha carbon?
one.
Yeah, one alpha. This only one alpha carbon here.
Yeah.
Yes, sir.
And Khadija, you tell me how many alpha carbon here?
One.
One. Okay. Uh, beta carbon. Yeah,
Two,
yeah.
sir.
Two. This one is also beta carbon. This one is also beta carbon, right?
Yeah.
Yes, sir.
Khadija, this
Yes,
one
sir.
is also beta carbon. This one is also beta carbon, right?
Yeah.
Now, now tell me, uh, according to you, which one will show beta elimination in the first question?
The one with the one with bromine.
See, what is the condition? Condition is that we should have one alpha carbon and beta carbon should have at least one hydrogen. See, from the definition, at least one beta hydrogen, right?
Yes,
So,
sir.
do
Yes.
we have beta hydrogen here available here? Yahya and Khadija,
Yes, sir.
Yes, yes, sir.
do we have, alpha beta hydrogen here? Is there hydrogen present
Yes,
in
sir.
it?
Um.
Yes. So yes. Uh, so this is, uh, here we can have, we will eliminate this hydrogen and this bromine out of here, right? And what will
Yes,
happen?
sir.
We will eliminate these things. Acha, we can eliminate from here also. There is no issue in it. Okay, we can eliminate here also and here also. So since this compound is symmetrical, so we don't have to worry about it, right?
Yes, sir.
Huh. So finally, we will get the compound. This, sorry, there will be the bromine will go and we will get this, right? Or this. So we will get this in this one.
Yes,
Are
sir.
we good here, Khadija?
Yes, sir.
In similar way also here also the chlorine will go out and this hydrogen will go out, or either this hydrogen. So finally we will get this or this, right?
Yeah.
Yes, sir.
So finally we will get only one product and the both pair will show beta elimination.
Eliminate.
But which one will be faster?
The one with bromine.
The bromine will be the faster one. Khadija, is it okay for you?
Yes, sir.
Okay, wait for a minute. I'm call. Hello. 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 Hello.
Hello, sir.
हाँ. So is it clear? Clear?
Yes, sir.
चलिए. So
Yes.
we'll see the next thing. So have you solved this one?
Yes, sir.
So what is the answer for you, Yahya?
Uh, Meaning, sir, like complete answer.
You can say complete answer also.
I'm getting, sir, I think double one dash PR will be zero.
Okay. Khadija, you got anything? Khadija, are you there?
Yes, sir.
Okay. Okay, let's try this out. We should not waste our time. So let's see. Here, this is alpha carbon. Okay.
Yes,
And
sir.
this is beta carbon. This is also beta carbon. So, and this is also beta carbon,
Beta
right?
carbon. Yes, sir.
So we
Yes, sir.
have three beta carbons, and every beta carbon has, this
Beta hydrogen.
hydrogen with it. So we can eliminate beta hydrogen, and yes, there will be beta elimination
Beta
possible.
elimination.
Possible. Yeah, right.
Yes,
So
sir.
Yeah.
we will form this, and wait, and one double bond will be present with it, right?
Yes,
And
sir.
we will have symmetrical structure, so we will get only one product, right?
Yes, sir.
Yes,
See,
sir.
see this example. In this is a alpha carbon, right? And this is a
Yes, sir.
beta carbon.
Beta carbon.
So does beta carbon have any hydrogen in it?
No, sir.
So beta carbon has zero alpha has, beta carbon has zero beta hydrogen, right?
Yes, sir.
So there will be no elimination reaction.
But, sir, the other beta carbons have beta hydrogen. No?
No, these are alpha, beta, gamma carbon. These are gamma carbons. You know, they are very far away. And this one is first one, this is second one, and these are third ones, right?
Yes, sir.
This one is primary, this is secondary, and these three are tertiary. We are only concerned with secondary ones.
Secondary.
Okay.
Okay, sir.
So
Yes, sir.
Khadija, you understood the
Yes,
issue
sir.
problem here?
Yeah.
Okay. So shall we move to the next?
Yes, sir.
Yes, sir.
Okay. Acha, kindly note it down first. I'm going to write another statements.
Done, sir.
Good.
Done, sir.
Now note down this question. This is question from NCRT, important one. It has been discussed in your syllabus. So reaction of write with me. So have you understood the question?
Yes, sir.
uh, Actually the aqueous alcoholic KOH, this reagent has been used first time in your syllabus, right?
Yes, sir. Aqueous KOH.
So earlier you may have used alcoholic KOH, like in SN1 SN2 reaction also you have used alcoholic sorry, aqueous KOH, and this OH minus will act as nucleophile and will attack on substrate, right? Like for example, let me show you, if you haven't forgotten, like this is Br, and if this is aqueous KOH, if nothing is written, assume it in aqueous form only, means KOH has been mixed with water, so it will be as aqueous KOH, right?
Yes,
and,
sir.
and if KOH will be potassium hydroxide is mixed with alcohol, if it is since it is soluble also, and then it will be known as alcoholic KOH. Okay, so what
Yes,
will
sir.
happen here, this OH minus will attack on this, sorry, will attack on this one and will form this. So this is a substitution reaction, right?
Yes, sir.
Do
Yes,
you,
sir.
do you remember, Khadija?
Yeah.
Okay, but here what is happening, this is this is taking this Br and H, and this bond is formed. So there is a huge difference in here, so we have to compare and discuss that why this is happening. Okay. So you have to know the answer also, and this can come in your exam, and you have to understand the concept also. I will write first, and then we will discuss what is actually happening. Let me know after you have written the answer. I will start explaining.
Done, sir.
Done. Adija, done.
Done, sir.
Done. See, this is a statement, but we will understand it from diagram, and it will be very clear to you. Okay, and then we will explain the statements which we have written. Okay, so see, there is an in alcoholic KOH we have alkoxide ion, as we have written in the above statement, right? So alkoxide ion is what? Alcohol is CH3 CH2OH, ethyl alcohol, right?
Yes, sir.
Okay. So we are going to make ethyl alcohol. Okay, and this is in ion form. Okay, because this is this is in this form actually. Okay, this O minus is getting stabilized, having formed ionic bond with K plus. Okay, potassium, right?
Yes, sir.
But we will for reaction it will not be needed. Now what is our purpose? We have to do reaction in an hydrogen haloalkane. So this is an haloalkane, right?
Yes, sir.
We have made this haloalkane, and this is a reagent. This alcoholic KOH is a reagent, and we are going to do some reaction in it. Okay, and there is another one which we have to compare with SN reaction. Okay, we have aqueous KOH, and we have alcoholic KOH. So see, in aqueous KOH, it is very easy, but we will understand it here by this OH minus. This will attack on this carbon atom, right?
Yes, sir.
So
Yes.
this is a nucleophile, and it is attacking on this carbon. May I know why it is attacking on this carbon, not this carbon? Just for the sake of knowledge.
Because it's attached to an halogen.
What?
Because it's attached to a halogen.
Yeah, because it has been attached to a halogen, and halogen has partially negative charge, and this has got some partially positive charge. So this is a nucleus level thing. This is a nucleophile. This is attack. This will attack on some positive charge, some some electron deficient atom, right?
Yes, sir.
Because this is electron rich atom. This is electron deficient atom. So it will attack on this carbon. Okay. And what will happen when this will attack on this carbon? This bromine will just leave. Okay.
Yes, sir.
Yes, sir.
So this will leave, and the product will be formed as RCH2 CH2OH. No problem.
No,
No
sir.
problem, sir.
Okay. Now what we will do? Acha, can you see this is this O minus? This can also attack on this carbon, right? There is
Yes,
a
sir.
possibility that this oxygen can also attack on this carbon. Why? Because oxygen is O minus is a nucleophile. It can attack on this, right? This carbon,
Yes, sir.
but this will not happen. Why? Due to large size. I hope you understand that this whole size is very very much big compared to OH minus, right? And there is a very little space present here, so it cannot attack this whole big group on this carbon. Okay,
Yes, sir.
So what alternate path it will take? What it will take? This will attack on this, you know, beta hydrogen, and it will, you know, capture it. And what will happen? This shared pair of electron will, you know, make this pi bond, and since it will make double bond, and this after this making double bond, this bromine will leave. Okay, and what will happen finally? We can see what has happened, that this RCH double bond CH2 will form. See why? Because this bromine has already left and this hydrogen is removed. Thus, this double bond has been formed. Okay.
Yes, okay, sir.
So you understood that what is the real, who is the real culprit here?
Yes, sir. OH.
OH. Yes. No, no, no. OH. Yeah, that one is
Oh,
culprit here. Means why it is not forming an alcohol? Why it is forming alkene? Khadija, you tell why it is forming alkene. The what? Who is the real culprit? What is the driving force that alkene should be formed, not alcohol?
Um, sorry.
See on the screen what I have written. Can you see the marker?
Yeah.
Because of large size, this size is so much large that it cannot attack on this carbon. Yes.
Yes, sir.
So it is, you know, removing this hydrogen, and thus alkene is formed. Okay.
Okay.
Okay. So you may have understood this concept, that this reagent is acting as a base because it is very large size, and aqueous KOH has no issues because OH minus ion is very small, and it will attack as a nucleophile. Okay. Now
yes, sir.
note down this, and you know, make these arrows like I have made. Very
Yes, sir.
important. Let me know when you are done.
Done, sir.
Done, sir.
Okay. So let's move to the next point. That what is Setzer-Full? You know, Setzer-Full talk about the formation of major product and minor product. Okay. So let's see what is the rules. What the rule says, that hydrogen. Write with me so that we don't have to wait. As you know, there are several operations from where it can, it can take beta hydrogen, as you have seen above. So let's see some examples where we are getting different products, and what the sets of rule exactly says. Okay. So have you written on the
Yes, sir.
definition, Khadija? Khadija, Khadija, can you hear me? See, you're here. See,
Yes, sir.
how many alpha hydrogen is there? Sorry, alpha carbon is there? Only this one,
One,
right?
sir. One, sir.
One. How many beta?
Two.
This one and this one, right?
Yes, sir.
Okay. So this compound is not symmetrical, right?
Yes, sir.
So we can see that here three hydrogen is three beta hydrogen is present, right?
Yes, sir.
Here three beta hydrogen is present, and here two beta hydrogen is present, right?
Yes, sir.
So by definition, you can see the hydrogen is removed from that beta carbon which has less number of hydrogen. So this beta carbon has lesser number of hydrogen, right?
Yes, sir.
So hydrogen will be removed from this part. Okay.
Yes, sir.
So when it will be removed from this part and bromine is removed from this part, so if we can say that double bond will be formed in this carbon between this carbon.
Yes, sir.
So finally, we can conclude that yes, this is a major product. This is a major product,
Major part.
and this is a minor.
Minor part.
Khadija, have you understood this? Khadija, I think Khadija cannot hear me or cannot speak. Okay. So understood this point?
Yes, sir.
Okay. Can you see like 336 alpha hydrogen is present in with respect to this pi bond, and with respect to this pi bond only two alpha hydrogen is present.
Yes, sir.
So in the other way, in more advanced way also, we can say that the more stable alkene which is finally formed is the major product. Okay.
Yes, sir.
Because 1 2 3 4 5 6 alpha hydrogen is present, and here only this and this two alpha
Two.
hydrogen is present, right? So
Yes.
this one is more stable, so major product will be this only. Okay.
Yes, sir.
From that only this another definition has been deduced, that more substituted alkene is the major product of beta elimination, because this alkene is is more substituted. But just remember first point only, that will be give then teacher will give you full marks only, don't worry about it. Okay.
Okay, sir.
Okay. So you understood till this point?
Yes. Yes, sir.
Okay. So let's do some questions. uh, Kindly write these down. I am writing down the questions. Have you copied this example, major one and minor one?
Yes, sir.
So the major product is also called Setzev product. Setzev product. This is called Hoffman product. Done?
1 minute, sir.
Okay, Khadija,
Yes.
where were you? Have you understood this Setzev rule?
Yeah.
Okay, good. Now try solving these questions. Done writing the questions?
Yes, sir.
Mhm.
Okay. Okay, let's try these questions out. So, see, when iodine will, get out of this, we have this beta, beta carbon, this beta carbon. So both have beta hydrogen with it, right?
Yes, sir.
So we will form this thing. Okay, the hydrogen will be eliminated, or we can form this, this bond here also. If anybody will form bond here also, there is no issue in it. Okay.
So which one will be the major and which one will be the minor one?
See, so let me draw this for you also. So you will get this one, right? So the the point which you have raised, that which one is major and which one is minor, there is only one product only, because this is a symmetrical one. So you can see this is, by, if you will name it by IUPAC, the both products are same, right?
Yes, sir.
So we will not, you will not say here that both products are, since both products are, we will not say that one is major or one is minor. Okay.
Okay.
Okay. So in this example, the product will be formed like this, right?
Yes, sir.
Okay. And Khadija, can you see, we will, if we will make double bond here also and here also, the product will be same only. Okay.
Yeah.
Okay. So now this is a example which you can see. This is an alpha one, this will be beta one, and this will be beta one, right?
Yes, sir.
So this is a not, this is a non-symmetrical compound. So what will happen? We will get, we can get two types of product. If we will remove, first I will make the, the skeleton of it. Okay. If we will remove hydrogen from this part, okay. Hello.
Hello, sir.
So
Yes,
if
sir.
we will remove hydrogen from this part, then alpha beta bond will form here, right?
Yes, sir.
And if we will remove alpha beta from this part, then the bond will be forming here, right?
Yes, sir.
Okay. So the number of hydrogen present here will be 2. There is 2 beta hydrogen, right?
Yes, sir. Yes, sir.
And here is only 1
One.
beta hydrogen, right? So
Yes, sir.
from the definition, we know that we will remove
Second one will be
hydrogen
one.
from the which has lesser number of hydrogen. So we will this will be the major product, right?
Yes, sir.
Khadija, can you see it?
Yes, sir.
Are we good?
Yeah.
Okay. Now in the next question, this one is alpha, this is beta carbon, and this is beta carbon, right?
Yes, sir.
Yes, sir.
How many beta hydrogen present in here?
3 beta hydrogen.
3.
3 beta hydrogen. And how many here?
1.
No, I want answer from both of you. Khadija?
Yeah. 1 beta.
Ah?
1 beta hydrogen.
No, there is no beta hydrogen here. See, if we will draw this, you know,
Oh,
can you see that
yeah.
this has, already bonded with four
Yes, sir.
things.
Yes,
So
sir.
we will have no, beta hydrogen here. So 0 beta hydrogen. So that is it. So we are bound to get only one,
1 product.
one product only. Okay.
Yes, sir.
Okay.
Yes, sir.
Now, see, this is alpha carbon. Okay. And this is
Beta carbon.
beta carbon, and we have one more beta carbon. Now tell me how many beta hydrogen present in here
2, sir.
2.
and here
0.
0. We
None.
have no hydrogen present in here, right?
Yes, sir.
So the bond will form in here, right?
Yes, sir.
That is it. So you have solved all the problems.
Yep.
Yes, sir.
Okay, good. So we will move on to next topic. So are you having any question regarding this beta elimination thing?
No,
No,
sir.
sir.
Okay, have you copied this? Copy it down. Copy it down first.
Okay.
Done, sir.
Done, sir.
Good. So let's move on to the next topic. Reaction with metal. Reaction with metal. So inshallah in next class your this chapter will complete this thing. So reaction with metal. So first of all, we will see reaction with metal. First one will be reaction with magnesium. Reaction with magnesium. So start writing down. Don't wait for me. See, this in this we are studying haloalkanes, right? So this is a haloalkane Rx. Okay.
Yes, sir.
So this we are going to react with magnesium. So first reaction with this magnesium. So when we react this Mg will get attached between R and X, and this is popularly known as Grignard reagent. The Grignard reagent is very popular. This name is very popular, and this is alkyl magnesium halide. Okay, and let's see what is happening in here. This X is, halogen. So this is attracting, electron pair with itself. So we will have partial negative charge here and here partial positive charge, right?
Yes, sir.
Correct. So so what will happen? This will react with each other, and finally it will form RMGX. And the most important thing about this RMGX is that, means the first time you will see this, that R is having this alkyl group is having partial negative charge. Okay, why this special thing has happened? Because magnesium is a metal, right? So metal has the tendency to, you know give electron, right?
Yes, sir.
So
Yes.
metal is giving electron, sharing sorry, metal is giving electron towards alkyl group. Thus alkyl has having some partial negative charge, right? So this partial negative charge is very important on alkyl group. So kindly note this down, that
Okay.
how this is forming when alkyl halide is treated with Mg in the presence of right. When alkyl halide is treated with magnesium in the presence of dry ether. Dry ether is very important here. Okay. In the presence of dry ether only this reaction is possible. Then what happens? That is why I have, marked this dry ether important. You also, make box around it. This reagent will come in later chapters also. The Grignard reagent. Okay. So when alkyl halide is treated with magnesium In presence of dry ether, it will form Grignard reagent. And let's see some examples of it. Similar examples, no problem, with dry ether. Okay, can you see, Khadija and Yahya, that this magnesium is going in between, this carbon and this magnesium, right?
Yeah.
Yes, sir.
Similar way, this very simple things, but just you have to understand it one time, and then you can, repeat it several times. Obviously, it will come here. Mg will get attached directly with it, and chlorine will come here. This will happen with every, every possible things. There is no rule for it that we have some alpha, beta, hydrogen, carbon, nothing else. Just if you see haloalkanes and magnesium with dry ether, just form a Grignard reagent. That is it. Done?
Yes, sir.
Okay. So till here, you got any problem, Khadija and Yahya?
No, sir.
Yes, sir.
Means you have problem. You can ask it.
No, sir.
Okay. So we will, deal with this. Why we are using dry ether? Actually, when we will use, normal ether, so there will be some moisture in it, and if there is some moisture, then it will form, the reaction product will be finally form alkane. So how this is forming with the mechanism, we will, uh, deal with it later. Okay, in the next class. Got it?
Yes, sir.
Okay. So फिर ठीक है ना? अस्सलाम वालेकुम.